Antarctica stands as Earth's most frigid and frozen expanse. While this frozen land mass might seem barren from an aerial perspective, beneath its icy surface lies a complex and enigmatic realm that scientists believe holds vital clues to understanding the impacts of climate change on our planet. Recent research indicates a rapid decline in the mass of the Antarctic ice sheet, with glacier within this icy expanse now melting at a rate 6 times faster than 4 decades ago, largely due to rising ocean temperatures. According to data from NASA, Antarctica is losing a staggering 252 gigatons of ice annually, equivalent to the volume of 3.5 Olympic swimming pools every second. Concerns are growing that within the next decade, the Antarctic ice shelf could fracture, leading to a significant rise in sea levels. What drives these anomalies in the Antarctic continent, and what consequences will they hold for us? These are critical questions to consider. The Antarctic convergence marks the boundary of the icy and remote southern hemisphere region, where the cold currents from the northward flowing Antarctic waters meet the warmer waters of the world's oceans. Covering approximately 20% of the southern hemisphere, Antarctica ranks as the 5th largest continent in terms of overall area, surpassing both Oceania and Europe combined. Its unique status as a continent devoid of a permanent human population sets Antarctica apart, with its landscape largely dominated by the imposing Antarctic ice sheet, recognized as the largest single mass of ice on Earth. During the transition from summer to winter, the ice surface in Antarctica undergoes a dramatic expansion, increasing from roughly 1.2 million square miles at the end of summer to about 7.3 million square miles by winter. This substantial growth primarily occurs in 2 coastal regions, namely the Ross Ice Shelf and the Ron Ice Shelf. These coastal ice shelves are extensions of the landmass, connected by sheets of floating ice that receive glacial ice from the interior of the continent at rates ranging from 10 to 1,000 meters per year. In comparison to other continents, Antarctica plays a significantly larger role in regulating the planet's thermal balance. Ice, being more reflective than land or water, serves as a powerful mirror for solar radiation. The vast Antarctic ice sheet reflects substantial amounts of solar radiation back into space. However, as global ice cover, including ice sheets and glacier, diminishes, the Earth's surface absorbs more solar energy, disrupting the balance of heat. This imbalance contributes to the ongoing phase of climate change, characterized by global warming. Interestingly, NASA researchers have observed a paradoxical trend in which certain regions of Antarctica are experiencing increased ice formation due to climate change. They attribute this phenomenon to the emergence of new climate patterns induced by climate change itself. The polar vortex, a robust wind pattern driven by various atmospheric processes, has been significantly impacted. Since 1980, the strength of these winds, which effectively lower Antarctic temperatures by up to 15 degrees Celsius, has intensified in recent years. However, not all regions of Antarctica are experiencing the same effect, as some areas witness ice melt despite the overall strengthening of the polar vortex. Alarmingly, scientists have issued a warning: within the next decade, an Antarctic ice shelf could fracture and collapse, potentially unleashing a glacier the size of Florida into the ocean, leading to a significant rise in sea levels. Scientists suggest that a critical chain reaction within the ice may commence as early as 2031, starting with the Thwaites Glacier. Previously considered relatively stable, Thwaites has been closely monitored by scientists and already sheds around 50 billion tons of ice annually. Recent observations reveal that the eastern ice shelf of Thwaites Glacier is exhibiting deep, mobile cracks, visible in satellite imagery over the past few years, which demonstrate a concerning trend of accelerating expansion. Positioned atop an underwater mountain, the eastern ice shelf plays a crucial role in impeding the glacier's flow into the ocean. According to the study, fissures have emerged at the top of the shelf, advancing at a rapid pace of up to 1.2 miles annually toward its center. These fissures, expanding several miles each year, are gradually traversing through the ice, their trajectory leading them toward areas of weaker, thinner ice where they could potentially accelerate, resulting in the melting of this section of the ice shelf within the next 5 years. Studies comparing aerial photographs of Antarctica from the 1970s with recent radar data reveal a far more rapid melting of Thwaites than previously anticipated. The potential collapse of Thwaites raises concerns, as the majority of West Antarctica's ice would be discharged. Consequently, there is a pressing need to enhance our understanding of how the glacier will behave over the next 100 years. According to estimates by the British Antarctic Survey, Thwaites currently contributes 4% to the annual rise in sea levels. However, if the shelf were to collapse, this percentage could surge to 25%. Should the Thwaites Glacier completely melt, sea levels would increase by 2 feet. However, if its melting triggers adjacent glacier to melt as well, global sea levels could rise by up to 10 feet. Last year, a significant event unfolded as a massive iceberg, approximately 1.5 times the size of Greater Paris, broke away from the Brunt ice shelf in Antarctica. Radar images captured by the Copernicus Sentinel-1 mission depict the iceberg breaking free and swiftly drifting away from the floating ice shelf. Meanwhile, glaciologists have been closely monitoring the development of numerous fissures and chasms in the Brunt ice shelf, which boasts a thickness of around 150 meters. Recently, a fresh crack was discovered in the ice shelf north of the McDonald Ice Rises, advancing towards another significant crack near the Stancomb-Wills Glacier tongue. Satellite imagery revealed that this latest fracture was rapidly traversing across the ice shelf, prompting careful observation by researchers. During one of these research expeditions to an Antarctic ice shelf, scientists came upon an unexpected discovery, a previously unknown ecosystem concealed within an underground river flowing beneath an Antarctic ice sheet. A camera lowered into the cave by a scientific team, after drilling through the ice shelf, initially revealed only hazy particles resembling debris drifting about. However, upon closer inspection, live crabs were captured on camera. As the camera descended into the river, it encountered hundreds of amphipods, small shrimp-like crustaceans, swarming around it. This exploration unveiled dozens of different living organisms thriving in a small area of the seabed deep beneath Antarctica's ice shelves, showcasing an astonishing diversity of animal life in a place devoid of sunlight. Life can indeed thrive deep beneath the Antarctic ice. These dark realms, devoid of sunlight, were traditionally thought to lack sufficient food to support diverse life forms, as most ecosystems rely on photosynthetic organisms like plants or algae. However, this vast expanse of ice shelves in the ocean remains one of the least explored underwater environments on Earth. The recent discovery of abundant life in such harsh conditions serves as a testament to the remarkable resilience of Antarctic marine life. Explaining the existence of this vibrant ecosystem beneath the Antarctic ice continues to intrigue scientists and underscores the complexity of life in extreme environments. Marine life, particularly filter feeders like bryozoans, sponges, and jellyfish, were previously thought to become scarcer with distance from the open sea. However, these animals are actually thriving beneath the ice shelves, preying on microscopic organisms carried by ocean currents. The organisms inhabiting the seafloor beneath the polar continental shelf and ice-free water are not limited by food scarcity. In fact, they receive an abundance of food that exceeds their consumption needs. These animals, which typically adhere to the seafloor and have relatively low metabolic demands, can sustain themselves on the modest amount of food available to them. The remarkable species diversity observed in this ecosystem may be attributed to the absence of disturbance. Unlike terrestrial environments that experience storms, floods, and fires, these underwater habitats beneath the Antarctic ice remain undisturbed, providing the necessary time and stability for species to proliferate. However, these pristine environments face an existential threat from human-induced climate change. As the Antarctic ice shelves melt, these distinctive habitats are at risk of disappearing irreversibly. Once lost, the ecosystem cannot be recovered. This discovery underscores the urgent need to understand and protect these unique ecosystems before they are lost forever due to the impacts of climate change.